Now, what is the cost function? The cost function, uh, you know that in commerce you have studied that there are two kinds of cost. First is the fixed cost and the other is the variable cost, right? Now,
Sir, in economic study.
in economics you have studied. So you have a fixed cost and you have a variable cost. One is a fixed cost which will not depend on the output or the number of units that a factory is producing. Okay, and like for example, the salary of the gatekeeper. Whether your factory is in work is in progress or not, it does not matter. You will have to pay him, right? For example, the rent, whether it is in progress or not, you will have to pay the rent. These are the head that come under fixed cost. Variable costs, in fact, depend on the number of units that you are producing, number of units that a factory is producing. Okay, it is called X is called the number of units produced, or demanded, or simply it is called the output. Okay, you produce as much as you have an order, right? Suppose you have an order of 50 units, you will only produce 50 units, right? So that is why it is called number of units demanded, or simply it is called output. Now there are certain costs that will depend on the number of units that you are producing. For example, electricity. The more that you produce, the more electricity you will be using, and therefore more electricity bill you will get, right? Labor cost, daily labor cost. The more electricity that you produce, the more unit number of units that you produce, you will require more daily laborers, and therefore you will have to pay them more, right? So that is these such heads are called variable cost. Fixed costs do not depend on the number of units produced. Fixed costs are whether you produce 100 units, whether you produce 1000 units, you will have to pay that fixed amount. Okay. Variable cost will depend on the number of units produced. So therefore, the cost function or the total cost function is denoted by Cx. It is a function of x. It is equal to f, the fixed cost, plus the variable cost, which is also a function of x, where f is the fixed cost, constant. Fixed cost is a constant, and Vx is the variable cost. Okay. So F is a fixed cost and V is the variable cost. V as a function of X, obviously. Okay, let's see an example. Here, if you see, I've given you an example. Cx is equal to A plus Bx plus Cx square. This. This is a total cost function. Here, if you see, the constant part is A. So therefore, this will be the fixed cost. Which part contains variables? This part, if you see, Bx plus Cx square. This is your variable cost. This is fixed cost F, and this is your variable cost Vx. It is a function of X. Okay. Similarly, the next one that you see, this part here is your fixed cost F, and this part here is the variable cost Vx. Okay. So that is these are the two examples. Next is what we define as the demand function. The demand function is the function of the number of is the function of the price per unit or the selling price per unit. If X is the output, or number of units
Yeah,
demanded. Yes.
Output means the number of goods sold or the number of goods produced.
Number of goods produced is equal to number of goods sold, because you are producing
O-
as much as the number of units are demanded. Okay, number of units demanded. Then the demand function is given by x is equal to number of units produced is equal to some function of p, where p is the price per unit or the selling price per unit, where p is the price per unit. Okay, sometimes instead of expressing x as a function of x, p is represented as a function of x. Okay, so this is also a demand function. Okay, so whether x represented as a function of p, price per unit, or p represented as a function of x, in both the cases you call it a demand function. Normally you will get I think this, okay, p is equal to gx. In the problems you're going to get p in terms of x. Very hardly you get x in terms of p. But even if x is given in terms of p, uh, the problem will be such that you will be able to express p in terms of x. Okay, and this is a more convenient form of the demand function, p in terms of x. Next is the revenue function. Now, just as your total cost function, you have a total revenue function. Remember, total revenue function is equal to quantity sold into price per unit. So price per unit you will have into output, you can say. Why output? Because you are producing as much as is demanded, right? You're not producing more, you're not producing less. So you are selling as much as you are producing. So you can call it an output. So price per unit is into output, and price per unit is P, and the output is um, and the output represented as a function of in terms of demand function is P into um, GX. Okay, quantity sold. Okay, output is X and into P. Okay, so this is X, and P in terms of demand function is into GX. This we get from demand function. Okay, so remember, total revenue function is denoted by Rx, this symbol. Rx is equal to x into P is equal to x into Gx. Okay, next we come to the profit function. Now profit function is very simple: total revenue function minus the total cost function. Profit function is sometimes represented as Px. Okay, next very important concept called the break-even point. Have you done break-even analysis in any of your other subjects, economics or accounts or anywhere?
No,
Have you? You have not.
no, sir.
Okay. Now break-even point. Remember,
Revenue,
you yes.
revenue function, there's a one chapter like cost and revenue. We have done sums on that,
Hmm.
but no, not no break even, something like.
Okay. There is a separate chapter in finance which is called the break-even analysis. Okay. Anyway, the definition remains the same. Fundamental concept of break-even is the same. So let us define break-even point. The break-even point is is the level of output at which the revenue function is equal to cost function. That is where the level of output at which the profit is zero. The level of output at which the profit is zero is called break-even point. That is, for remember this condition, for break-even point, profit function must vanish. That is, revenue function minus cost function is equal to zero. That means at break-even point, always revenue function will be equal to cost function. Okay. So when revenue function is equal to cost function, you'll be able to find out X. And that is the level of output at which your revenue will be equal to cost. For example, if you are producing, say, 20 units, at 20 units of output, you'll be able to make a no profit, no loss scenario. But say if you make 30 units, then you'll be able to make profits. If you make 15 units, then you will be able to make loss. But at 20 units, definitely you will have a break-even point. That is, your total revenue will be equal to your total cost. You'll be able to recover your total cost. Okay. Now let's talk in terms of curves. If you see here, I have drawn something called as a cost curve. This curve is called as the cost curve. Okay. And this curve is called as the demand curve. For example, if you have a function of Cx, then you can always plot a graph. If you plot a graph, you will get a graph something like this. And this graph will start from here because definitely you will have a fixed cost, certain fixed cost you will have. And the variable cost will be given by each point of this graph, by the ordinate of this graph. For example, if you want to find out the variable cost at, say, x is equal to 20, then you draw an ordinate here. Then this point will give you the y coordinate of this point will give you, that means this length here will give you the variable cost at x is equal to 20 units. Okay. So there, similarly, you can find out variable cost for any value of x that you want. Okay. See that when the x is equal to 0, the variable cost is 0. Okay. In fact, you have variable cost not equal to 0, but you have variable cost equal to, you have the total cost equal to the fixed cost. Okay. Similarly, you can have a revenue function also, because revenue function is sorry, you can have a demand curve also because you have a demand function. What is the demand function? Demand function is x is equal to fp. Okay. So you have, when you draw the demand curve, you will be able to get the demand at each point on the demand curve. For example, for different prices, what is the demand? Okay. For example, let us say at you want to find out the demand at, let's say, price is equal to 10 rupees. You want to find out the demand. How will you find out the demand? This length is your demand at 10 rupees. Suppose now if you increase the price of the article from 10 rupees, say, or let's say you decrease the price from 10 rupees, say you decrease the price to, say, 5 rupees. So obviously if the price goes down, the demand will go up. So therefore, your demand will be this. Is it clear? Cost curve and demand curve.
Yes, sir.
Okay. Okay, you can note this also graphically, although you will not get graphs, but still graphically the break-even point is the intersection of the total revenue curve, not the demand curve, and the total cost curve. Okay. So for example, if you have two curves like this, you have your, say, cost curve, and let us say you have your revenue curve. This is C equal to CX, the cost curve, and this is revenue curve, R is equal to RX. Okay. The origin. This is X, and this is obviously, what should I say, cost or amount, money or amount, right? This point that you get here, this is called the break-even point. Okay. At this point, your total revenue is equal to total cost. So that is what the graphical interpretation is. Now let's start with problems based on what I have explained, uh, so that they get the whatever result that I have explained gets fixed in your mind. First is, a shoe manufacturer is planning production of a new variety of shoes. For the first year, the fixed cost for setting up new production line is rupees 1.25 lakh. Variable cost for producing each pair of shoes is rupees 35. Okay, so variable fixed cost is 1 lakh 25,000, 1.25 lakh. Okay, so fixed cost. So given here is fixed cost F is equal to rupees 1.25 lakhs, which can also be written as in rupees in this manner, right? And what is the variable cost given? Variable cost is given to be 35 per unit. Variable cost is equal to rupees 35 per unit. The sales department projects 1500 pairs can be sold in the first year. That means what is the number of units demanded? 1500, right? At the rate of 160 per pair. Okay, 160 per pair means price per unit is how much? Price per unit is rupees 160. So one unit, one pair of shoes is sold for 160 rupees. Okay, sales department projects 1500 pairs can be sold in the first year. So let's take note of this, that 1500 units can be sold in the first year. Now let's see, answer the first question. Determine the cost function for the total cost of producing X pairs of shoes. So F fixed cost here is, right? Let the output be X. Number of units produced or number of units demanded be X. So therefore, what is the variable cost? Total variable cost. Variable cost is 35 per units, but how many units are being produced? X. So total variable cost is 35X, right? So therefore, what is the total cost function? Cx is fixed cost plus total variable cost. That is, Cx is equal to 1,25,000 plus 35X. This is your total cost function. Okay, that answers the first question. Second question. Determine the revenue function for the total revenue from the sale of X pairs of shoes. I've already assumed this to be X. So what is the total revenue function? What is the price per unit here? The price per unit is 160. Therefore, total revenue function Rx. What was the formula for total revenue function? Price per unit into number of units produced or demanded or output. That is Rx is equal to price per unit is how much is given here? 160. And number of units produced is X. So that is your total revenue function, 160X. Next, profit function. Determine the profit function Px for the profit from the sale of X pairs of shoes. So profit function Px is equal to Rx minus Cx. That means Px is equal to 160X minus total cost function 1,25,000 we found above plus 35X. 160X minus 35X equal to 125X minus, fine. This is the total profit function. Okay, next question is, if 1,500 pairs are actually sold, what profit or loss would incur? 1,500 units means 1,500 units sold means 1,500 units demanded or level of output is 1,500. So here X is equal to 1,500. Therefore, profit that the company would incur is equal to, the profit function here, put it in this. P 1,500 is equal to, put X is equal to 1,500 here, 125 into 1,500 minus 1,25,000. Okay, so this will come to 1,87,500 minus 1,25,000, which is equal to rupees 62,500. This is the profit that a company is making if it sells 1,500 units. Clear? Next question is, determine the
Yes.
break-even point. For break-even point, remember the definition of break-even point, that the total revenue function must be equal to the total cost function. Or you can also say profit function is equal to 0, any one. Okay, so here, what was the total revenue function? We found above the total revenue function, if you see, we found above it to be 160x. And the total cost function also, we found above to be 1,25,000 plus 35x, right? So this is what your cost function was. Now we can solve this equation. That means if we solve, we will get 160x minus 35x is equal to 1,25,000. That means you get 125x is equal to 1,25,000. That means you get x is equal to 1,25,000 divided by 125. X is equal to 1,000 units. So how many units need to be produced so that to cover your total cost? If you produce 1,000 units, you will be able to cover your total cost. Okay. Is this clear? This problem or any question from this?
No,
Devanjan?
sir.
No, sir.
Let's attempt the second question, and that should be it for today. This is a very easy concept actually. And in fact, in the first part that I have discussed just now, there is nothing related to calculus, nothing even close to calculus in this. The calculus will start from the next part. Okay. Look here, a profit-making company wants to launch a new product. It observes that the fixed cost of the new product is 35,000. So given here, fixed cost is 35,000. Okay. And the variable cost per unit is cost per unit is equal to rupees 500. The revenue received on the sale of X units is given by, so the revenue function is also given to you, Rx. Revenue function is given. Fine. First question is profit function and second question is break even point. So profit function, obviously you need to find out the cost function, right? If X be the output, is the level of output or number of units produced or the number of units demanded, then what is the total cost function? Cx is equal to total fixed cost plus total variable cost. In this case, the fixed cost is given to you as 35,000. And what is the variable cost per unit? 500. But how many units are being produced? X units. So total variable cost will be 500x. This is your total cost function. Now, once you have found out the total cost function and the revenue function is given to you, you'll be able to find out the profit function. Hence, profit function. Px is equal to revenue function minus cost function. That means Px is equal to 5,000 x minus 100x square minus 35,000 plus 500x. Okay. Open the brackets. Okay. Now take the x square first, then your x's together. You have 5,000 minus 500 will give you plus 4,500x. And you have a minus 35,000. This is your profit function. Okay. That answers the first part of the question. Next question, if you see, is determine the break-even point. What is the break-even point? For break-even point, the total revenue function must be equal to total cost function. Or you can also say profit function is equal to 0. You can also put Px is equal to 0 and proceed. Okay. So revenue function here is 5000x minus 100x square is equal to 35,000 plus 500x. You take everything on the right hand side, left hand side in fact, to get minus 100x square plus 4500x minus 35,000 is equal to 0. Now you need to solve this equation to get the value of x, the break-even point. You take minus 100 common, you'll get x square minus 45x plus 350 is equal to 0. That means x square minus 45x plus 350 is equal to 0. That means now you can factorize this. Middle term factorization is minus 35 and minus 10. That means now I can take x out to get x minus 35. And here also I get x minus 35 by taking minus 10 out. Therefore, x minus 10 into x minus 35 is equal to 0. Means either x is equal to 10 units or x equal to 35 units. That means when 10 units are produced or when 35 units are produced, the revenue function will be equal to the cost function. Both these are called break-even point. This is also a break-even point. This is also a break-even point. So you're getting two break-even points. Fine. Any question?